In this video, we discuss about discrete random variable and certain terms associated with discrete random variable, namely the probability mass function and the cumulative distribution function. We know that discrete random variable takes on finite number of values. Now we define probability mass function PMF. The PMF helps us to understand discrete random variable. Now it is indicated as Pxx, small p, capital X within brackets small x. Now how to understand this? This is the probability of random variable x takes on the value small x. The capital X indicates the random variable and small x is the value taken by the random variable capital X. Now with this diagram we try to understand what is Pxx, that is PMF, probability mass function. This PMF word is specific to discrete random variables. It describes the discrete random variable. Now from the diagram, how we understand this? There are three values taken by the random variable x. As it is a discrete random variable, here the discrete random variable is taking on three values x1, x2 and x3. Now how we understand this diagram? The probability of the random variable taking the value x1 is 1 by 4. The probability of random variable x taking the value x2 is 1 by 2. The probability of random variable x taking the value x3 is 1 by 4. That is how we describe discrete random variable in terms of probability mass function. So we have seen that PMF gives us the probabilities with which x1, x2 and x3 happen in the previous diagram. Suppose if I say Px(x1), it is the probability of the random variable x taking the value x1. Now we have two important properties of this PMF. The first one would be sigma for all values of x, Pxx is equal to 1. And we readily agree that the sum of probabilities would be always 1 for all values of x. Secondly, the Pxx is greater than equal to 0. And this is also evident that probability is always a positive number. It could be 0 or greater than 0. It is always a non-negative number. Now, normally the random variables are described in statistical terms. Therefore, we have certain statistical averages to describe random variables. One such statistical average is expected value. It is also known as mean value. So expected value or mean value is simply the average value of the random variable. Now how we define mean value or expected value? The expected value Ex denoted as Ex. E stands for expectation of random variable x is equal to mu x, that is mean of the random variable x, is given as sigma x x Pxx. That is its summation of all product terms formed by the random variable x with its PMF. So this is the definition of expectation value or expected value or mean value. And we can also interpret the expected value as center of gravity. Now we take one example on expected value. This diagram gives us the PMF of certain discrete random variable. Now understand this diagram. Here the random variable x taking the value 2 with the probability of 1 by 4. The random variable is taking the value of 6 with the probability 1 by 2. It is taking the value of 10 with the probability 1 by 4. So here x is taking 3 values. Now I want to calculate the mean value or expected value. We know the equation. It is sigma for all values of x. It is the product of x with the PMF for the respected value. Here S has got 3 values and we have 3 probabilities. Now if I substitute the values Ex, we have 2 into 1 by 4, the first term, and the second term is 6 into 1 by 2, we have second term, and third term is 10 into 1 by 4. Summation of all these terms gives us 6 as expected value. Now we go for the concept of CG, center of gravity. This concept of center of gravity simplifies the calculation of mean value in certain cases. Now in the same diagram, treat these probabilities as weights, weight 1 and weight 2. Suppose I redraw this diagram here at 2 and at 10. At 2 we have a weight of say 1 by 4, and at 10 we have a weight of 1 by 4. Now to keep it at equilibrium, we require center of gravity at this point, equidistant. So 4 units from this side and 4 units from this side. So center of gravity lies here. So it is naturally would be 6. By looking at the diagram, 6 is equidistant from 2 and 10. And their equal weights are there here. So center of gravity lies at 6. So by looking at the diagram, we can readily say mean values is 6 without even going for the formula. That is the advantage of the concept of CG. Now we go for expectation of function of a random variable. Suppose we take a function y is equal to gx. It means y is function of random variable x. Now here it should be clear in our mind that function of a random variable is also a random variable. Therefore, y is also a random variable. Now if you want to calculate expected value of the function or expected value of random variable, which is a function of random variable, that is in this case Ey is equal to Egx. Substitute gx in the place of y, and that is given by E of gx into pxx. We can readily adapt this equation. Suppose for simple random variable we have sigma x pxx. If this is function, then simply replace this with function value, and that is given by now sigma. In the place of x we get gx pxx. That is all. We are readily adapting this equation to a function. We now discuss another term associated with random variables, that is moments. Moments are generally defined as, suppose first moment of the random variable is defined as sigma x x pxx. It means it is nothing but the mean of the random variable x. So moment of x is the product of first moment means x power 1 into its PMF. Similarly, the second moment of random variable is Ex square. Second moment means x to the power 2. So second moment of random variable is Ex square. Therefore it is given as, in place of x we are keeping x square pxx. As we are finding the mean value of x square, it is also known as mean square value. It is a very important term used in the literature. These terms moments and mean square value, expected value, mean value, all are used in the literature. So what we understand here is, first moment of random variable is nothing but the expected value, that is definition is sigma x pxx. Second moment is square of the x. Suppose if you want third moment, it is ex cube and so on. So in general, for nth moment of a random variable, it is given as Ex power n. It is sigma for all values of x, x power n pxx. Suppose if n is equal to 1, it leads to first moment. If n is equal to 2, it leads to second moment. So this equation is general equation for nth moment. We have three properties of expectation. The first one is expected value of constant is constant itself. Here alpha is a constant value. We understand that for a constant value, average value is the constant value itself. So expected value of a constant is always a constant. The second one is, suppose you multiply the variable x, random variable x with constant alpha, then what is its mean value? Now substitute alpha x into the equation. By definition, we are substituting alpha x in the place of x and pxx. Now being alpha a constant, we bring it out and it gives us alpha ex. From this equation, we understand that if you multiply the random variable with a constant, its man value is multiplied with a constant value. Thirdly, if you have alpha x plus beta, mean value of alpha x plus beta, it means you are adding beta to alpha x. Then what happens? Again, you expand this equation. We have alpha x pxx and beta is brought out and we can write it as beta into sigma x pxx. You just expand this equation. From the basic definition, we substitute in the place of x, you are keeping alpha x plus beta and expanding it. And then you get alpha ex plus beta. So what we understand from this, if you add some constant to the random variable alpha x, then its mean value is shifted by beta. So these are the three important properties of expectation. Till now we discussed about expected value or mean value. Now we go for another important term associated with random variables, that is variance. Very important concept or term associated with random variable. How variance is defined? Variance x is expected value of x minus ex whole square. Now let us understand in simple terms how we are calculating variance x. Variance x is, firstly we are taking the difference of random variable with its mean. Try to understand clearly. First we are taking the difference of random variable with its mean and we are taking the square of this and then we are taking mean of this. So that gives us the variance. So variance is the expected value of the square of the difference between random variable and its mean. So that is how it is defined. Now I'll expand this. Variance x is, if you expand within this x minus ex square, ex whole square, there are three terms. So as per expected value definition, if we expand this, we get three terms like this. And after simplification, we get ex square minus e square x. And we also know ex, that is expected value, is also known as mean value. If I suppose, if I indicated this with mu x or even m for simplicity, small m, then we can write ex square minus m square. That is, variance is given by the expected value of square of x minus square of its mean. It means it is the difference of the second moment minus square of the first moment. This particular equation helps us to calculate variance in clear terms, in easy terms. So it is given by the difference of the second moment minus square of the first moment. We take one example for finding out variance of a given random variable. So this is the PMF given to us. We need to find out variance for this particular PMF. From the previous example, we calculated the mean value of this particular variable is 6. If we go for center of gravity, it is at 6. Therefore, the mean value or expected value of this random variable is 6. Now, how to find out its variance? It has got two steps. First step is we are finding the square of the difference, x minus ex whole square. This is the first step. Second step, we are finding mean value of this. So by doing these two steps, we are finding out the variance. Now let us do it pictorially. With the help of diagrams, we can find out variance. So first step is x minus ex square. That is difference of random variable with its mean. So from the given diagram, for the first term, we have the difference is 6. That is mean value, difference between mean value and random variable. That is 6 minus 2 square. So that is 16. Here 6 minus 6, that is 0. Here 10 minus mean value, that is 6, that is 4. 4 square is 16. Therefore, we have the first one, square of the difference terms. That is plotted here in this second diagram. I again try to repeat this. The first term is mean of the difference of this random variable with its mean. 2 minus 6 square, that is 16. Similarly, 6 minus 6 square, that is 0. And 10 minus 6 square, that is 16. So this is completing our first step. Second step is we rearrange these terms because 16 with 1 by 4 and 16 with 1 by 4. We can combine these terms and find out its mean. That gives us variance. We do that in the next slide. From the previous diagram, we got this diagram, sum of squares. We can understand that we have two similar terms there with 16 1 by 2 and 16 1 by 4 and 16 1 by 4. So if we add, we will get 1 by 2. So in this diagram, we have two terms, 0 with 1 by 2 and 16 with 1 by 2. So first step, we calculated x minus ex whole square. This we completed. This is given by this diagram. And second step, we have to find out mean of this particular value, mean of this. That gives us variance. Now find out mean of this diagram. We can readily go for the center of gravity concept. 0 and 16, the center of gravity lies here at 8. Therefore, mean of this particular value is 8. Therefore, the variance of above example is found to be 8. Thus, certain properties of variance. The first property is variance of alpha x is greater than or equal to 0. It means it is a non-negative or positive number. We know the variance of x is expected value of some square. Therefore, is always supposed to be a positive number as a non-negative number. The second property is variance of alpha x is alpha square variance x. Suppose you multiply the variable x with the constant alpha, then how its variance is affected. Now variance alpha x is alpha x minus e alpha x whole square, and for that we are taking expected value. And we expand, then we get alpha square variance x. What does it mean? If you multiply a random variable with alpha, its variance is multiplied by alpha square, because variance of x is ultimately the square of the difference, expected value of square of the difference. Therefore, if you multiply variable alpha, random variable x with alpha, its variance is multiplied by alpha square. And thirdly, suppose if you are adding a constant beta to alpha x, then what is its variance? Variance is not changed. Whatever variance for alpha x is there, it remains same. So if you are adding beta or a constant to the random variable, we already seen in the previous discussion in the expectations that if we are adding a constant, its mean value also is equally shifted. So if the mean value is equally shifted, then there is no difference in the square of the component. Therefore, there is no change in the variance value. So if we are adding a constant to the alpha x, its variance is unchanged. Previously, we discussed probability mass function, that is PMF. It is denoted as probability of the x taking the value x. Now we go for the cumulative distribution function. The cumulative distribution function is denoted as capital Fxx. The capital X stands for the random variable, X the value taken by the random variable. Now the CDF, that is Fxx, is denoted or defined as probability of the random variable X taking the value less than or equal to X. So now how we define CDF is denoted as Fxx. It is nothing but the probability of the random variable X taking the value less than or equal to X. So this is the concept of CDF. So CDF and PMF are very important to understand the discrete random variable. Here I given this same diagram, and for this diagram, this is the diagram of PMF. And for this diagram, from this PMF, I want to draw CDF, how it looks like. That we'll see in the next slide. We are drawing the CDF for the given diagram. For the case of clarity, I'm just redrawing the previous example again here. So let us draw it again. We have here 2, 6 and 10, and here we have 1 by 2. This is 1 by 4, and here we have 1 by 4 again. This is the PMF diagram given to us. And for this diagram, we want to draw CDF. This is PMF diagram, that is PXX. These are the values of X. For this diagram, we want to draw the CDF. Now, what is CDF? The cumulative distribution function Fxx is defined as probability of X taking the value less than or equal to X. And here we have three values, 2, 6 and 10. For each of them, we try to find out the cumulative distribution function, and then we redraw it here. Firstly, we consider the probability of less than 2 is 0 here. No, the probability of 2 is 1 by 4. It means for less than 2 it is 0. Therefore, the first term is for probability of 2 we have 1 by 4. And then we are going for 6. The CDF of 6, that is Fx6, is nothing but probability of X less than or equal to 6. The probability of X less than or equal to 6 involves two terms. That is probability of X is equal to 2, that is here, and probability of X is equal to 6, that is here. So probability of X less than or equal to 6 involves two terms, this one and this one. So if we add that, we get 3 by 4. So probability of X less than or equal to 6 is picking up 3 by 4 here. Now the third term is 10, probability of, that is Fx 10, taking the value of 10. It has got three terms now. It is probability of X is equal to 2, probability of X is equal to 6, probability of X is equal to 10. If we add all three of them, we get 1. So the probability of X less than or equal to 10 is raising to 1 at this point. If you combine, we will get this type of diagram as CDF. So this looks like a staircase function. It is something like a staircase function. So the CDF of a discrete random variable is staircase function. So in this video, we discussed about discrete random variable and the probability mass function, and then certain statistical averages like expected value or mean value and variance values and their properties. And finally, we concluded with the concept of cumulative distribution function. As we discussed earlier, the PMF and CDF concepts are very much essential for understanding discrete random variable.